Hi, you're welcome to Kanga Academy Tutors. The name is still Kanga Desmond. It has not been changed. And today we are going to look at some lessons about how to design a cadastral plan. So, in designing a cadastral plan, we all know that we use AutoCAD. And with this one, you see, in designing a cadastral plan, you have two, I don't know whether there's more, but for now I know you have two file extensions you can use with AutoCAD to design a cadastral plan. I have the SUR, I have the carlson. So today I'm going to take you through the carlson software so that you know how to go about it in using it to design cadastral plan. The next time we focus on the SUR tool. So for the carlson, it's an extension of which when you install it on a PC, it gets attached itself to the AutoCAD so that you can use it to do whatever you want with your AutoCAD. So now we are going to use it to design our cadastral plan. Now I've gone to the folder and I've picked my points. So these are my points. Okay, let me open them. So this is my point. It's opening. So this is my point. I picked 4 points. So you have the first point, second point. So in uploading a point onto AutoCAD with a carlson survey, the input it takes is 5, let's say 5 points or 5 columns. The first one is the point, have the northings, have the eastings, have the elevation, and have the description. That's how points can be what imported into the survey, a carlson survey. And the order should be point, northings, or your Y, or eastings, or your X, and the elevation or your Z, and the description D. So that's the order of which your point has to be. So now I'm not using, or I'm not having the elevation, I'm not having the description. So now you're going to focus on the point, northings, and the eastings. Okay, so with this, just go to or just open your AutoCAD. So AutoCAD, I'm having my carlson. You can see carlson survey 2021 with AutoCAD. Okay, so what I'll do is that I'll just go to point, then go to import text or ASCII file, then go to select text or ASCII file, and now browse to where I saved my file. So it's on the hot desktop. So you can see this is the desktop. I'm choosing that one, but still my point is not showing. This is because the file type which is active is what, the test.txt. I have to change it to .csv. So I'll just click on .csv, then it's now showing. So I'll just select it, click on open, and then click on open again. Now this is my point. Now this is the coordinate order. Now because I'm not having the Z, these are the order formats. We have that one for the space, comma delimited, space, comma delimited, space, comma delimited. Okay. But because I'm not having the Z, I'll delete the Z and the D. If you're having it, you can just type comma then add Z, comma, you add your what, your D. But I'm not having it, so what I'll do is that I'll what, delete it because I'm not having it. Okay, and now what I'll do is that at the draw point section, click on this one and choose draw locate point. Draw locate point. Okay, and then click on OK. Now I'll give, I'm doing a new work. It's not an existing work. So here I'll choose what, new. I'll just give the name of my work. So I'll just write Ames work. Ames work. So this is the name of my my work here. I just click on open. So to say it's reading this number of points by one, so it will skip one. That's what located. Okay, so these are points. You see, it's showing us this one. So one is the whole description. This is the word my point, but it's showing another feature here. This one is the elevation, but we were not having the elevation data and we don't need it. So what we do is that we just select everything, just right click on it, want to delete it. Okay, and just okay, before that let me show you the point. So just select it, right click and go to properties. You can see this is my point. You have the y point, x point, and what, the z. So you can see the z is what, 0 0. Yeah, the z is 0 0. Okay, so now I have to what, eliminate that one, and you can see that everything is being grouped to be one. So first I have to what, ungroup it before I can what, delete it, or just select everything, right click, go to group, ungroup. Now I'll select again, right click, and then I will go to quick properties, and then select everything, delete, enter, and then close, escape, exit that command. And move on to the next one. I'll select everything, right click on group first, select, right click, quick properties, then backspace, enter, close, escape, the group, select everything, right click on group, then right click, properties, enter, close, escape. Onto this one, right click on group, select, right click, quick, enter, escape. Okay, so now I now have my point. So now it is time for us to join our boundaries. Now we're going to use a line, but you have to get the exact point or the exact location. Because if you don't do that, the coordinate will change. And if you import your point, don't try to move any point, because if you move any point or if you try to move this one, the coordinate and everything will change. Okay, so don't move anything. Okay, so what I'll do is that before I'll do that, I have to get the exact, I want to get the exact point here, so therefore what I'll do is that I'll just type snap, that is object snap. It's to help me to get the center. So I'll just open it. Now the node to help me to get the exact point, to do something like an X to indicate me the exact point, and this one will indicate where the center is. This will also indicate the center. Then this one will indicate where when there's a midpoint, or if you want to get a midpoint, and this one to when if I want to get the intersection. Now you can select everything, does not matter. You can select everything, but for sake of this tutorial, we'll check these ones. Okay, so just click OK. Then I want to join with line, so just type line. So line has appeared here. I'll just select it. Okay. So now starting with one. Okay. My arrangement wasn't good, so I have to do something about it. Then I come here. You see, if I bring it here, this is my node. But if I bring it closer and the center shows, see, to indicate the center. I bring it to the center, show me my node, and I get the point. Okay. Then so center node, and now I'll join it. Okay. Then escape. So these are my boundaries. So these are my boundaries. Okay, now I want to change the point labels, because we have one, two. So if I wanted to use how I labeled it to draw my boundary, like I'll mess up. So what I'll do is that I want to change it. So I want to make it 1, 2, 3, and 4. So what I'll do is that I'll just come here, select it, right click, go to quick properties, then come here, just make it 2, enter, then I'm good to go. Then I go to this place, here will be 3, select, right click, quick properties, then 3, enter, I'm good to go. Escape, select, right click, quick properties, 4, then I'm good to go. Okay, now I'm done with changing points. So now it's left with me to add the bearings and the distance. So in carlson survey, whenever you want to add the bearing and distance, you go to annotate, then go to bear angle and distance. Then come, you will see many descriptions here. This one, they all do different things. So if you go to the bearing, this one is trying to tell you that it is showing you the bearing, but it will be indicated above the line. So when I click this one and I choose bearing, see it is giving me only the bearing, but it is what it is over the line. So when you choose this one to annotate angle and distance, when you choose this one is also giving you a bearing, but it will be under the line. This one will give you bearing and distance, but will be in something like a fraction form. The bearing will be over the line and the distance will be under the line. This one is also telling you that you can see something here, something small symbol here. Distance will be above the line, bearing below the line. You can see something here. You have bearing and distance. This one will be, they will be in a straight line, but the bearing distance will be above the line. This one, they will be in a straight line, but they will be below the line. This one is showing you only distance. The distance will be above the line. This one showing only distance, but it will be below the line. And this one, they will be in something like a fraction form, but they will all be above the line. This one will all be in the fraction form, they'll all be below the line. So this one, the bearing will be first, followed by the distance, but they will be below the line. This one, the bearing will be first, followed by the distance, but they will be above the line. Then this one, the distance will be first, followed by the bearing in the fraction form, but they will be above the line. This one, distance first, bearing the fraction form, but they will be below the line. I hope you get it. This one it is showing me the azimuth, but it will be above the line. This one is showing me azimuth, but below the line. This one azimuth and distance in the straight line, but they will be above the line. This one azimuth and distance in the straight line, but they will be below the line. This one azimuth and distance in the fraction form, but the azimuth will be first, followed by distance. And this one distance in the azimuth, but the distance will be first, then followed by the what? The azimuth below the line. So this one, as I explained earlier, this applies to this one. The one. So in this one, there are two types of bearing it being showcased here. And this one, so what this one will give us is this one will give us a quadrantal bearings within a quadrant. So if I choose bearing and distance for this one, I want to get the bearing of this line. If I click on it, you see it, we have south east. So if let's say if I draw my plane here, I have my north south, I have my east and the west. So if I want to get my bearing, you see this line is between the eastern and the southern, but the main post of which we consider is the what? The north and the south. So considering that we use that to get our bearing. So the main posts are the north and the south. So anytime you are naming a quadrantal bearing, the main post will come first before the east and the what and the west. So you have south. You have from the south to the line. The angle is bigger than that of the what? From the east to the line. So when dealing with quadrantal bearings, always the angles are being taken from the main post, as the north and the south. That's it for quadrantal bearings. So that's why we have south of 75, 27, 36. So from the south, so we have south, then it goes here, then 75. See the angle here is very small. Hope you get it. Thank you for get on it. Get on it. Okay, so this is for what? Quadrantal bearings. Now let's go to the azimuth. Okay, sorry. So I go to annotate. Now when I go to azimuth, so when I click it, you see the azimuth is giving me a bearing. If you're now using it for the first time, you see that they will indicate here AZ, meaning that azimuth. Okay, and the azimuth, it has a settings, or everything has a settings. You have to decide whether it should give you a back bearing or it should give you a forward bearing. You see, so if you choose away from break point, it should give you a forward bearing. So meaning that it's moving away from the what? The break point. It will move it's what moving away from the break point. But if you pick or if you take towards the break point, it's giving what? A back bearing. So let me show you. So you go to annotate default. When you come to angle, so you can see bearing direction method. So you have toward pick point, away from pick point. If you pick toward the pick point, it means they're giving you a back bearing. If you pick away from pick point, it's giving you a forward bearing. You can test this one too and see how it works. Okay. Then the azimuth, the AZ, this is the prefix. So if you want to include the AZ, you can just type AZ here, then everything will show. If you want to give a prefix for the bearing too, you can bring it here. Okay, so it depends. So this is the settings. You can note it. We are working in degrees, minutes, seconds. Okay. Then my distance, I'm working it. I'm working in what, decimals. So I'll just pick the decimals. Okay. So that's how we're good to go. Okay. So now this is what we want to go with. We want to go with forward bearing with what our distance in decimals. So we go to annotate. Then I'll pick azimuth. Azimuth distance. So I'll just click here, indicate it. Click here, indicate it. Click here, indicate it. So you can just do a manual computation to test whether the bearings are correct or there's a mistake. So you can just take one point, let's say this one. Because we picked a forward bearing, I'll start from here. I'll draw my plane. Then I have my east, west, north, south. So if I draw my bearing from the north to come to this line, then you can see it is getting close to what, 180, but it's more than what, 90. You can see it. So that's why we have 159. So you can see it makes sense. The same applies to this one. So when I draw my plane here, so away from point, see, away from this point, then I'll draw. It is more than what, 90. You can see. So you can just do a manual computation to check whether your bearings are correct. Okay, so this is the end of today's tutorial. This is the end of today's tutorial. Please subscribe, like, comment, and click on the bell so that anytime I upload a new video, you get an alert. Thank you very much for watching, and God bless you. If you don't have the carlson, so we just comment. I'll make it available for you to get it in our next tutorial, and I'll help you to install it. Thank you very much for your time and everything. Please don't forget to subscribe. Tanga Academic Tutors. If if you have any topic or anything you want me to make a video of, you can just comment it and I'll do my research and make it available for you. Thank you very much.